the Bohr's model. Bohr's model, right? So basically, what was the problem? Okay, let's see. So first of all, we will see hydrogen spectra. Spectra. So the thing was that it was observed that in the hydrogen spectrum, there were only four wavelengths that were emitting, that were coming out. That were 656 nanometer, 486 nanometer, 434 nanometer, and 410 nanometer, and in between them there was no radiation, right? It means it was like discrete sort of thing, that only these four were coming out. So it was a big question that why only these. So to explain this, Bohr's model came out, right? Earlier we know that earlier we knew that the electrons are like revolving around the nucleus, but there was a problem using the Maxwell's electrodynamics theory. In that we knew that if electrons are revolving like that, so it will emit their energy in the form of EMWs, and in that case it will come and collide with the nucleus in less than 10 to the 1 negative 8 seconds. Then why atoms are so stable? So to explain that, Bohr's came, right? Okay, so let's see how he contributed in that. Okay, so you all must have learned that in your school time also, that how the things are going, like this is your, he assumed this is your charge, this is ZE, and this is the electron that is revolving around this, right? Somewhat like that. Okay, he assumed this. Okay, so suppose there's a electron at infinity, at that point it will have an energy equal to 0. It is obvious. So when you're bringing it from suppose here to here, and then it starts to revolve. So at that point, what is its energy? Its energy is equal to half mv square plus the potential energy. What is the potential energy? It will be, this is a negative charge, so it will be plus some constant 1 upon 4 pi epsilon, and for free space it's epsilon naught k into ze into negative e by r square, and the r is the nuclear radius, right? So you get it is equal to half mv square plus minus kze square by r square, right? This is the concept. Okay, so this is your first equation for now. I'm sorry, I just drew line that like that. I hope it's clear. Okay, and the second equation, that mv square by r is equal to kze square by r, right? Is it okay? Sorry, it will be r, and here it will be r square. Okay, but what are we even calculating it? We are calculating. So Bohr stated that there are orbits along the orbits in which the electrons are present, and except those orbits, the electrons can't be present in between them. For example, this is your first orbit, this is your second orbit, this is your third orbit, and so on and so forth. So between them, the electron will not be present. It will be on present in the orbits, right? So that is the basic idea of Niels Bohr, and in that he stated that when the electron is in this orbit, it won't either emit nor absorb any kind of energies, right? And that was a significant role to explain the stability and the spectrum of the hydrogen atom, right? Okay, so basically this is the thing. Okay, so assume that this electron is revolving along this circle with a frequency nu, right? Okay, so basically when you solve this, you get mv square is equal to kze square by r. So basically this is equal to mv square, so energy is equal to half mv square minus mv square, which is equal to half, negative of half mv square is equal to energy, right? This is the equation, right? And this is the equation that the centripetal and centrifugal forces are being equated, right? Okay. So basically, and now there was a assumption made by Bohr. What was that? When you are bringing this electron from infinity till here, it is emitting a photon, a energy equal to negative n h nu by 2. Why a negative sign? Because the photon, that is the photons which are going, when it is going from here to here, it is being emitting, right? So that photon will have a positive energy, but in the process the electron lost its energy, so in that process, that is why it is negative, right? Okay, this is the energy, that is energy of the electron over here. And why nu by 2? It is because over here there is no energy, and over here there is no photon, and here it is a new frequency. So in that process, it is the average nu plus nu, no, nu plus 0 by 2. So it is nu by 2, right? I hope you are understanding. Basically, when the electron is going from here to here, it is emitting photons in the form of energy nu by 2, right? So this is the second thing which you are calculating, and this is another equation which you are having. So combining these three, you can end up getting the results which we usually see in the copy in the books, that it is equal to like negative z square m e4 8 n square h square epsilon naught square, whatever, using these equations. Why? You use v is equal to r omega, and v, the velocity is equal to r omega, and from that, you know, omega is equal to 2 pi nu, and you can compare this nu with the velocity, it is v. So we get v is equal to r into 2 pi nu, right? We get this, you substitute it over here, you get m into r 2 pi nu whole square is equal to k z square by r, and you have this relation that energy is proportional to nu, and solving all these three equations, you will end up getting this thing. Okay, basically you have to eliminate v, r and nu, basically, to get this relation. Okay, n is the orbit number, okay, over here. So this is how the concept of energy came from this, and from that you can calculate r, and you can calculate the velocity and whatever things which you want to calculate, right? And from all this, he came with the relation L is equal to n h bar. What is h bar? H bar is equal to h by 2 pi, right? H is the Planck's constant, right? Obviously, you should know that. So L is the angular momentum and is equal to mvr. So generally, when we are taught in the textbooks, we are said that it was a postulate of Niels Bohr that L is equal to nh bar, but it was proved afterwards by him in the same research paper. But he assumed this thing, and from that he got this, and from all this he got this actually. So that is the big difference, what we are taught and what is the reality. Okay, so let's move to, yeah, and obviously if you see the delta E, the change in energy, it is equal to minus me4 upon 8 epsilon naught square h square into z square into 1 upon n1 square minus 1 upon n2 square, right? It is like that, and from this you can calculate, you can set it equal to hc by lambda, put n1 as suppose any quantity, and then you can solve it, right? And in that, and using this you can prove that the lambda, the frequencies and the wavelength which are being emitted is just it is in the form of a discrete value, right? It is in the form of a discrete value, using this, since n1 and n2 are the integral values, so that is why they are not continuous. So that is why when the energies are being emitted, they will be emitted in the form of a discrete pattern. So that is why we are getting 656, 480, like those values I don't remember right now.